EPA's Office of Transportation Air Quality, where I work, oversees federal transportation emission policy development, testing, research, modeling, and analysis. We manage our nation's renewable fuels program, we oversee air quality compliance for mobile sources, and we lead in innovative voluntary programs like SmartWay. So in a way, the office where I work is kind of a microcosm of the federal government's approach to reducing air emissions from transportation. One of our nation's greatest policy success stories is the Clean Air Act. As a result of these health-based vehicle, engine, and fuel emission standards, today's new freight trucks are far cleaner than trucks of just a few decades ago. And you can see from the unregulated 1980s that tiny little, there's a tiny little box, there it is, there it is, and that represents emissions today coming out of the tailpipes of new freight trucks that are sold on the road. And it's important to state that environmental achievements can go hand in hand with growth. In the US, as overall criteria, air emissions were decreased by over 70%. Energy use, population, vehicle miles traveled, and gross domestic product all increased. But today we face a new challenge, climate risk. And this year, for the very first time, US greenhouse gas emissions from transportation surpassed those of greenhouse gas emissions from the utility sector. It's the same story globally. CO2 from freight transportation contributes 30% of all transport-related CO2 emissions and is by far the fastest growing source of greenhouse gas emissions in transportation. It's growing faster than passenger transport greenhouse gas emissions. While transport-related greenhouse gas emissions from light-duty vehicles is expected to double by 2050, experts project that greenhouse gas emissions from freight transportation will more than triple during that same time period, and some even say it could quadruple. And this growth is due to a lot of different factors. Among them are changing demographics, rising consumer expectations, increased global prosperity and population, and the rise of global markets, to name just a few. But while these trends do promise a brighter future for most of the world's population, we really need to do more to decouple business growth from resource consumption and from environmental impacts. So I and my colleagues at EPA, we actually spend a lot of time thinking about the intersection of policy, technology, and the environment. Assuming that transportation will do its fair share to achieve climate stability, nearly all on-road transport, both personal and freight, would need to be close to zero emission by 2050. And this implies a shift to electric and fuel cell vehicles and a deeply decarbonized energy grid, perhaps 80% decarbonized or more. When I think of the existing heavy-duty truck production cycle, and when I think of how long it could take to turn over the entire legacy fleet of heavy-duty freight trucks and other freight equipment under business-as-usual conditions, I start to realize that we're nearly already there. It's already nearly 2050. Every day, we hear more promising announcements about another new electric semi-truck. However, these vehicles are not yet produced at scale. The grid is not yet decarbonized. We don't yet have sufficient low-carbon refueling infrastructure. We know where we need to go, and we know the straightest road to go there. But like the 40-year-old who realizes she just hasn't started saving enough for her retirement yet, our time horizon doesn't allow us the luxury of investing in just one area, like vehicle technology. We need good public policy, and we need multiple strategies, and we need to start implementing them as soon as possible. As this graph shows, and it's a little hard to read, truck-to-rail intermodal shift presents a feasible near-to-mid-term strategy, and other near-to-mid-term strategies include things that are accessible to us now, like packaging strategies, optimized supply chain networks, and more efficient operational practices. And that graph is courtesy of the Maersk Company based on some international reporting. However, what I want to stress here, if you don't know a lot about freight, is that goods movement is very complex. Our challenge is going to be to connect the hundreds of thousands of individuals and companies that each day make independent decisions about their supply chain. These decisions, which then impact the sustainability and the efficiency of the overall goods movement network, are often siloed within proprietary enterprise and communication systems. And the very nature of trucking itself presents another challenge. Globally, most domestic freight moves by truck. In the US, truck-only moves account for 62% of freight by volume of shipment and 60% by weight. Yet trucking fleets are overwhelmingly small businesses. In the US, only 3% of fleets operate more than 20 trucks. 64% of fleets in the United States operate 1 to 2 trucks. And in much of the rest of the world, a typical trucking fleet is one person with 1 truck. So think about this. At the heart of a $1 trillion supply chain industry on which global corporations depend are these little mom and pop trucking outfits. These micro companies have very small profit margins, and they have limited bandwidth for doing much other than their day-to-day work. They're often very skeptical of government or other external interests because they fear it will bring more control and higher cost. Yet because these micro companies in the aggregate comprise such a big chunk of the logistics industry, and they tend to drive the oldest, most polluting trucks, it's essential that smaller fleets be integrated into any new mobility future. And fuel prices alone won't do it, since freight demand is relatively inelastic to fuel price, and that's partly due to the industry structure. For example, truck trailers and rail cars can be owned by the shippers themselves or by leasing companies, and this creates split economic incentives. Shippers typically don't directly pay the fuel costs of the carriers that they use, and this reduces their incentive to invest in those carriers' technologies. And in the US, we also use a lot of freight intermediaries to do our business in freight. These are brokers, logistics companies, and non-asset-based carriers. And these third-party companies may have limited knowledge or control over the equipment or vehicles or operational decisions of the carriers and the shippers whose freight they represent. So the sector structure is one challenge. And coming right at us is another challenge. It's the onslaught of big data. Today, we generate 16 zettabytes of data each year. How big is a zettabyte? Well, if all 7 billion people on Earth tweeted continually for 100 years, it would generate 1 zettabyte of data, which is 1 billion terabytes. Experts project by 2025, the world will generate 163 zettabytes of data annually, which is a magnitude of order increase in just 7 years. In logistics, we're actually on the cusp of this freight data sphere with the advent of network computers, sensors, satellites, cloud platforms, and devices that's helping to create smart trucks, smart roads, smart locomotives, smart planes, and smart cargo ships. And you can see that big data presents both opportunities and challenges. Trucking fleets are already using telematics to monitor their driver behavior and their truck performance. They're using it to improve their driver training their programs. They're using it to improve their truck maintenance and their purchasing decisions. Some trucking fleets are using systems that electronically connect 2 vehicles in a platoon. The semi-autonomous, closely connected operation saves fuel by reducing aerodynamic drag. And manufacturers are working to develop more autonomous trucks. The promise of big data, however, is to go beyond these vehicle-based systems to integrate all entities within a supply chain network to optimize both assets and cargo flow. This will require very powerful data transfer, processing, quality assurance, and analytical capabilities. Data management and analysis on this scale will require cognitive programming like machine learning and artificial intelligence. We'll need sophisticated data integration platforms so data exchange is well-defined, transparent, and scalable, and so proprietary data can be protected. Some experts predict that an encrypted and distributed data ledger system like blockchain will fit into this logistics future. And companies are already gearing up for this. For example, UPS's Orion software has 1,000 pages worth of algorithms and 6.7 to the 190th possible alternate routes. It took them 10 years to develop, but they estimate that it's going to save them 10 million gallons of fuel and 100,000 metric tons of greenhouse gases each year. IBM is already working with Maersk Ship Line and 92 other companies on a distributed ledger system for shipping. It's already resulted in 154 million shipments, and they're adding 1 million shipments to the pilot each day. Beyond big data, we're going to see new freight modes emerge. Just as in personal transportation, where we have mobility as a service that combines transit, shared, and privately owned vehicles, a sustainable freight future will encompass new freight modes, alone and in combination. For example, we have for last mile delivery, a system that's being piloted by FAA and the Workhorse Company, which is a drone truck system. UPS also piloted a drone truck system where the drone loads and unloads while the truck is in motion. In cities, we're going to see more innovations like human-assisted electric pod delivery, autonomous delivery robots, urban drop centers, delivery scooters, and even crowdsourced shipping via rideshare and off-hour transit delivery. Freight hubs could be hubs of innovation. For example, Virgin Hyperloop is building a pilot Hyperloop system at the Port of Dubai to whisk containers away from the port without the use of truck or rail. People are also developing plans for more short sea shipping and for autonomous barges. And further into the future, we'll see more disruptive technologies, including 3D printed vehicle parts and lower carbon biofuels and nanomaterials. As you've heard throughout this conference, electric vehicles hold enormous potential. Of course, they're about 40% thermally efficient now. We can probably get them up to 50%, but electric motors are in the range of 85 to 90%, and they have far fewer moving parts. And although freight electric vehicles are not yet produced at scale across the freight sector, we are starting to see delivery EVs that can run on a single daily charge, with research underway to enable longer freight routes. One day, the road itself could charge electric freight trucks using inductive charging or overhead catenary lines. And hydrogen fuel cells are another option. I'll just whip through these. The program that I direct, SmartWay, is starting to build capacity in the freight sector with ways to exchange data and information using common measurement platforms, metrics, and methodologies that let companies exchange environmental performance about their supply chains confidentially and also reliably. And they use these results in their Scope 3 reporting and their sustainability reports. And the reason this is important is that it increases the visibility of the importance of greenhouse gas emissions to a company's carbon footprint, and it also contributes to that company's reputation among its employees, customers, investors, and other stakeholders. And sustainable business practices also protect and create market value while conserving the resources that companies need to operate. We're also helping the market to appropriately value greener technologies. For example, EPA verifies fuel saving and emission control devices and equipment for both our clean diesel projects and for our SmartWay partners. And in this way, government-led partnerships serve as test beds for new and emerging technologies, allowing them to be acclimated within the industry, and businesses later feel comfortable in using these to comply with regulation. Market-based programs complement national policies. Since 2004, SmartWay partners have saved billions of dollars in fuel costs while cutting millions of tons of harmful air pollutants. And the program currently operates in both the U.S. and Canada, and we've conducted training and technical exchanges in Mexico, Brazil, China, Vietnam, South Korea, Argentina, Chile, and elsewhere. So looking to the future, I can imagine a new mobility paradigm for goods movement where technology, data, and policy are seamlessly integrated to protect people and planet. I believe that that future is the one that most people in this room would also want. Thank you.